Everyone for being here. We've got about a 4-hour workshop that I'm going to run through in about an hour. All right. My name is Adib Saikali. I'm part of the Pivotal Platform Architecture team here in Toronto. If you find this that it caused your ears to bleed, I apologize. I hope it's not too much blood on the floor. Security is a very vast topic. If you want the slower 4-hour version of this, talk to me afterwards, and we'll schedule something. I'm assuming everybody here knows what a microservice is, because I'm not going to define it. Raise your hand if you know what a microservice is. If you don't, ask somebody who raised their hand what it is. Okay? So our goal is to secure microservices, and in order to do that, we have to actually see what the problem is that we're trying to solve. So our number one problem with microservice security is that microservices talk to each other. So I might have a situation where my circle microservice calls the triangle microservice, which calls the pentagon microservice. And this is no different than what you do today. You make calls over the network all the time in your enterprise systems. And how have we solved this problem since the beginning? Like this. We basically say, stop. Identity papers, please. So on the communication links, we need a way to know who's actually making the call. And if we know who that person is, we can actually make a security decision. Does that make sense to you guys? So if I want to make a security decision in the triangle microservice, I need to know who's actually calling me and what permissions they have and stuff like that. So that actually raises a bunch of interesting questions. The first of which is, OK, let's actually talk about what is being spoken on those communication links. So I'll open it up to you guys. What's the protocol that microservices are supposed to use? HTTP REST. Raise your hand if that's what you think they should use. All right, a whole bunch of you. Good. How about other protocols? What other protocols might you find yourself using? Rabbit. Yes, AMQP. Woohoo. Bonus points. How about Apache Thrift? Anybody heard of that? It's an RPC protocol that Facebook invented in open source. Or maybe you're kind of a hipster and you like to use gRPC, which is Google's HTTP2-based, mobile-friendly RPC protocol. Or maybe you have a custom legacy TCP protocol that you've invented that you have to support. So the key idea here is when you're looking at microservices security, do not make the mistake of assuming that it's only HTTP. If you haven't guessed yet, in this presentation, I'm going to spend a lot of time talking about the protocols and the patterns for microservice security. I do have a demo at the end that illustrates how all of this comes together with Spring and Spring Security. So the key idea, there's no best protocol. So whatever security mechanism we pick, we better make sure that it works with all the different protocols that we might use today or in the future. Sorry, you can have a... Sure. So our solution is that every request to a microservice is going to include a security token of some kind, which makes it easy to authenticate that and authorize that particular request, which says, OK, now you have changed the problem. So the problem of securing microservices becomes the problem of, well, what format should the security token be? What is the type of ID that the microservice is looking for? A passport, a driver's license, a birth certificate, right? Does that make sense? We're looking at how are the tokens supposed to be obtained? Like, where do you get the token from? What libraries are available in various programming languages for working with these tokens? What information should be in the token? What shouldn't be in the token? So these are all some of the design choices you're going to have to make. So what format should you for a token you should use? The answer is a standard token format. You don't want to invent your own, because inventing security token formats is quite hard. So what are the choices you have? Well, it depends on what's your favorite decade. If you like the 90s, you can pick Kerberos, OK? If you're using a Windows login, you are using Kerberos. Active Directory is based on Kerberos. If you like the 2000s, you can use SAML, which is XML-based. If you like the decade we're in right now, you can use JWT, or JWT tokens. So the interesting things about these token formats is that if you want to get yourself a SAML token, you need an actual SAML server. So the actual token format is related to the needs of the SAML protocol. If you want a Kerberos token ticket, you need a Kerberos server. You can't just get it from something else. The interesting thing about JWT tokens is if you want a JWT token, you can get it from anyone that's willing to give you one. There isn't actually a protocol tied to JWT. So when most of you out there type into Google Microservices Security, you're going to see all sorts of bits around OAuth, around JWT tokens, around various other protocols, and it's a mishmash of stuff which is kind of like really confusing to get through. So part of my goal today, and I hope at the end you'll agree, that this will be demystified. So decision point number 1, what token format should you use for your microservices? How many people here would guess that it should be JWT tokens? Raise your hand. Yes, I will arrive at that, but it'll take a few slides to argue why that is the correct choice. So questions to ask. Is the token format standardized? Can the token be used by any protocol? If I take this token and I try to stick it into a request parameter in an HTTP URL, will it work? Or will there be characters that violate the HTTP spec? Can I put it into an HTTP header? Can I squeeze it into a JMS header or a RabbitMQ header? So these are all various things that you know. Is the token easy in codes to work with? How many people here have tried working with SAML? Raise your hand. How many people would have preferred if you never started working with SAML? Okay. You know, it can be difficult to work with very complex standards. So if you look at what's out there today, this is a toolbox of standards. In the interest of time, I'm not going to read it. I'm just going to say that there's a whole bunch of RFCs that are from the same kind of group of people that makes internet standards. And when you look at all the standards, it kind of looks something like this. So at the bottom, you have these JSON web algorithms, JSON web key. On top of that, you have JSON web signatures, web encryption. On top of that, you have JSON web tokens. And then on top of that, you have OAuth 2 and OpenID Connect. So what I want to do today is I want to show you how to use what this layer looks like, why this is a decent set of choices, and how the whole picture comes together to secure the microservices. So first one of these, JSON Web Algorithms. You're probably wondering, what is this? It is effectively a list of standard names for algorithms. And the reason why is, if I'm going to exchange data with Luke over here, and I'm going to send him some encrypted data, he needs to know which encryption algorithm I used. So how do I tell him which one it is? Do I write it as a big long string that says I am using, you know, the RSA algorithm? Well, if it's the RSA algorithm, how big are the keys? What are the settings that are used to configure it? So this is about communicating security metadata. So that's basically what it is. So if you see, for example, the string HS256 that is from the JWA specification, it means that you're using the hashed message authentication code with the secure hashing algorithm that outputs a 256-bit hash. How many people here know what IANA is? IANA. IANA is like in the internet naming authority. You can go there and there's lists of stuff. So there's an actual registry of all the standard algorithms, what the strings should be, and what the matching algorithms are. So this is actually ridiculously useful if you have the following problem. Let's say you're going to encrypt some data and store it in your database. Who's done that? And as part of that, you actually want to know remember in the database, what algorithm you use to encrypt it. Now, what would you set in that column? You could put, you know, flags like algorithm A, algorithm B, algorithm C, or you could use JWA. So from now on, every time you're trying to remember what encryption or cryptographic algorithm is being used, check the JWA registry, see if there's a string that represents what you want, and use that. Then it's standard. Okay? Comments, questions? Guys, feel free to ask questions anytime. So, nope, we don't want that. So JSON web signatures, it represents content which is secured with message authentication codes or JSON web encryption eventually. I actually put the slides a little bit out of order here, but that's fine. So what I want to basically say is this. With digital signatures, what you can tell is if something's been tampered with, not stopping people from actually seeing what's there. So if you look at your driver's license, it has anti-forgery features. Like it has the little holograms, it has other things. It's not printed on a piece of paper. It's not like, the picture has all sorts of patterns in it, your photo, to try and like fight counterfeiting. So that's what it does. So it's a great format for taking some data that you have and then encoding it as a JSON object. Why are we picking JSON? Because everybody knows how to work with JSON. Every programming language has a nice friendly library for handling that. So here's what it looks like. If you look at a JSON token or a JWS token, you'll see that it has a header, which tells you what is the algorithm that's being used. You can see alg here, HS256. It has a payload. The payload is an arbitrary JSON string. The JWS spec doesn't say what should be there. You decide what you want to put in there. Right? And then there's an actual signature, which the format of this is going to end up matching whatever algorithm you're using. That'll depend on the algorithm what that would look like, the signature. So what this basically means is there's also what's called a compact serialization of JWS, which is you take the base 64 encoding of the header, you add a dot. You take the base 64 encoding of the payload, you add a dot. And then you take the signature, and then you put it all together into something that ends up looking like that. And this is a string that you can send around in URLs, in HTTP headers, anywhere you want. So what's lovely about this format is it's just a string. You can put a string in pretty much anything. It's not just a string, it's a string which has a URL safe encoding. Right? So that's why it's kind of like the JSON web signature. It's web friendly, but it has uses elsewhere. Yeah.
It could be a long string.
Yes.
Probably not in URLs.
Yes, it can definitely exceed the maximum header sizes that browsers and queries, but it depends on how big your payload is. Okay, that's usually what it is. That's the determining factor. Yeah. Could be a few kilobytes. So these are some useful features of JWS. You can store it in HTTP headers. Anyone can decode and view the payload. So remember that. If you have a JSON web signature, it doesn't mean I can't see what's in your payload. I can, but I can't change it, because if I do, you'll detect that when you validate the signature. Anyone can verify stuff, and it's easy to create these things and sign them with a digital certificate, which means that if I'm a microservice and I get a JWS, I don't have to go back to a server to check if this is valid or not. I can actually just use the public key of that server and see if this JWS is actually secure or not. Right? So if you are now going to send JSON documents, if you're going to receive them, if you're going to store an encrypted JSON document in your database, say, for example, yes, the credit card has been charged, yes, the money has been transferred, whatever it is, who thinks they would now consider using JWS as a data format for a field in the database? Perfectly valid. I mean, it makes it kind of a bit future-proof in the sense that you could decode it in the future easily. So the metadata is all in there. So there's another one, JSON web encryption. What do you guys think this will do? Anybody? Encrypt the payload. That's exactly what it does. So I'm not going to get into all the details. Again, it has a header that tells you which algorithm is being used, the key, initialization vector, the ciphertext, and authentication tag. So naturally, it's a lot bigger. Okay? What I find is most libraries I run into right now seem to all implement the JSON web signature. Very few seem to be implementing the JSON web encryption. I think it's just a matter of time before they do. So same kind of comments apply. If you're just working with JSON, you want to encrypt a piece of JSON, definitely take a look at JWE. Right? But this is getting us now up the layer stack to the JSON Web Token, which is the thing that we actually care about the most for microservice security. And as you can see from the diagram, a JSON Web Token is either something that's signed or something that's encrypted. Either one would be considered a JSON Web Token. Right? So the reason why we like it, the reason why we use it, is this URL safe and compact representation. We can put it in headers, we can put it in parameters, and we have a choice of which algorithms to use. So let's say you're deploying this. Your InfoSec team at your enterprise would be the one that decides which algorithms are allowed and disallowed. They might have opinions as to what is a safe digital signature algorithm, what's an unsafe one, what are the minimum requirements. Um, so a great place to learn about JWT is JWT tokens is to go to this place called jwt.io. It's got like a debugger. You can copy and paste your tokens in there, and it will validate them. But apparently, my screen is not big enough. My resolution must be 800 by 600. Ooh. Okay, let me see if I can fix that. Oh, much better. Okay. So if I go to jwt.io, can you guys see it throughout the room? And I can basically copy a token in here. We'll decode it. If you haven't played with it, it's kind of fun to do a bit of that. So what's interesting about the standard is it says, OK, what are some of the information you can put in the token? You might want to put the ID of the token. You might want to put when the token expires. You might want to put that kind of information. So instead of, since the standard is unopinionated about what you put in it, it has some optional recommendations. For example, if you want to know who issued the token, you would use ISS. If you want to know when the token was issued, you would call your field IAT, issued at. If you want to specify the user ID that the token belongs to, you would use sub. If you want to say when is the token expiring, you would use exp. Okay, but those are all optional. You don't have to use them. Recommend that you do so that you're interoperable with others. So here's how it ends up looking like inside of an HTTP request. If you look at the bottom here, what happens is that when you're making a call over HTTP to your microservice, you add an authorization header, and then you just add a bearer token. Very, very simple. You're not like making any kind of special stuff. Comments, questions about that? Okay, all right. So hopefully that's super easy. I have another thing here. Like sometimes you may want to carry extra tokens because you might have information about the call that's propagating down a line of microservices. Well, you could have your own custom headers for your own frameworks where you could put your own other JWT tokens in there that you could use for various pieces of information. So let's say now you're like, OK, I'm not doing HTTP. I'm now doing JMS, or I'm doing RabbitMQ. Then take your JWT token, stick it into a JMS header, or stick it into a RabbitMQ header, or something along those lines. You're going to have to, at the receiving end, look for that header. The advantage of this type of approach is because it's piggybacking off the authorization header that's part of HTTP, every web security framework understands HTTP authorization header. So typically, your web framework, like Spring Security, is going to look for that authorization header. It's going to decode the token. It's going to check the certificate of the token. It's going to check the token is not expired. It's going to do all that for you. You don't have to do anything. And I'm going to show you some code on that shortly, yes?
So when they check for whether a token is expired, does it use the contents of the token, or do you ask something?
So it would use, for example, to check expiry, you would first you could use the time that's in there, and since the token is signed, you can just check the clock.
So you're relying on that signature.
Correct. Yes. Now you are relying on that. The advantage that you get is speed, because you don't have to hop back to the issuer of the token and check if it's valid. However, you can do that. You can actually take the token ID out of the token, go back to the token server and say, hey, token server, I just want to check, is this token ID still valid? And the token server would tell you. You have a choice of how to use it. JWT doesn't tell you which way to use it. That's up to you. So if I was building an application where speed was super important, then I would use the digital certificate and the times to check. And I'm going to assume that my computers all have NTP and the times are within, reasonably synchronize the clocks. Otherwise, I'm going to code my application, if I'm really paranoid about security, to always go back to the issuer and say, here's the ID. is this token valid?
What contest is now is intra-company or internet or within a company. This security treatment, like we can extend to anywhere, right? Because when we talk about OAuth et al. Between
Yep.
companies or between entities, we have a federated OAuth, and there is some services who are comparing it. But then this one, it's all inbuilt, like composed message. So we can send intra-company also, right?
Yeah, so the comment that's slash question that's being made is that this JWT token format is useful to send not just inside of a company, but you could send it to external services you call, you could offer it up and expect it from partners. Like being a JWT token JSON based, it's easy to do that kind of thing. Now you're going to need to get into the higher level protocols around OpenID Connect and others to go like, what are the standard fields that I would put? I don't want to go there yet, okay? So we're going to speed up here a little bit. So the key idea is this. Every request to a microservice is going to have inside of it a security token. That security token, I receive the request, I look at the token, I use the information in there to decide if I should allow the request to proceed or not. Okay? And I'm going to use JWT for doing that. Very important, JWT versus OAuth 2. Keep in mind that OAuth 2 was created in 2012, and JWT was published officially in 2015. You can choose to use OAuth without using JWT. You can choose to use JWT without using OAuth. A lot of the time, people kind of like assume that they go together. They can, but they don't have to. Just making out a comment. So we figured out what format should our token be. Now let's take a look at like, how are we going to get these tokens? The answer is, well, you should get them from an OAuth 2 / OpenID Connect server of some kind. All right, that sounds good. How do we do that? So I'm going to skip here ahead and just I'm going to skip over this one too. Say, well, if you're going to go get them from an OAuth 2 server, there's actually 4 different ways you can do that. The challenge with these different ways is they're actually OAuth 2 is designed for asking permission of a user. So it's like, hey, Adib, do you want this application to be able to access your photos on Flickr? Hey, Adib, do you want this application to be access your calendar on Gmail? So it's about asking permission of the user that owns the data, whether they want it or not. Now, when I have microservices calling each other, I don't want to pop up a dialog box, hey, microservice number 27, way down the line would like permission if it can access these 3 database fields. Like, that just wouldn't make any sense. So we're not going to use all of the capabilities of OAuth for that. The thing that we're going to rely most for microservice security is client credentials. Okay? So I'm going to talk just a little bit about that. On OAuth, there are a server, a resource server, an authorization server, a whole bunch of client applications, and some people that own the resources, typically humans or other apps. And of these flows, the simplest one to get your head around is the the password credentials. I log in, I actually provide my username and password. So I'll demonstrate this real quick. Just need to open up a terminal. All right, so here I am. I'm going to do CF logout. Can you guys see my screen? Everybody? Font's big enough? I'll just make it a little bit bigger. So I'll do CF login. I'm going to log into Cloud Foundry. And you can see it's asking me for my password. And I type in my password. And I'm then going to be able to select and log it and complete the login. So now I can do things like use the application. But the key thing is I type my username and password into the application. Now, I don't have to keep logging in again. Well, where does this application store my username and password? It doesn't. What it does is if I go into my .cf folder, there's a file here called, config.json. I can open that up, and you can see in here there's something called an access token. And I can take this whole access token, copy and paste it, go over to jwt.io, remove this, There you go. And I can see like what algorithm is being used by Cloud Foundry to create the token. I can see the information that's been put in there. And you can see there's a lot more fields, including a whole bunch of fields that only make sense to Cloud Foundry. But that's an example of I get a token, and then I don't need to now store my password. I just store the token and send it back over and over again. Okay? Comments, questions? So that's kind of a simple one where you just get the username and password. There's a variant of this called client credentials, where it's not the human user's username and password, it's the actual application's username and password. So that's when I start up. Let's say I'm the microservice that transfers money. I go to the OAuth server and I say, hello, OAuth server, please give me a token. It says, why should I even talk to you? Well, here's my username and password, my client ID and client secret as the money transfer microservice. Who's with me on that? I'm not representing a user, I'm representing myself, the actual piece of software. So that's why it's kind of, this is kind of a bit useful. Yeah, question?
Doesn't that mean that anybody running that software can discover this?
Well, yes, if you have that, except that if you're talking about so the question was, if every application has a client ID and client secret, doesn't that mean that the person running that software has access to those? The answer is yes, but we're talking about microservices running in a data center. So when I go to deploy my microservice, I will provision brand new client ID and client secret. The other thing is the spec is kind of like says, well, you don't have to use a password. It could be certificate based. So I may authenticate myself to the OAuth server with a certificate.
It's the same as somebody knows user agent password.
Yeah, exactly. Well, I was thinking, you're running an application like, let's say, Cloud Foundry CLI. It has a secret. It must be in there somewhere. So if I run that on my machine and I'm a bit of a hacker, I can get the secret.
Yeah. So the comment is, if I'm running something like the Cloud Foundry CLI, the client ID and secret isn't a flow that you would use. Remember, there are 4 flows with OAuth, and you have to pick the right flow for the use case. So in that case, like client credentials would not be the right flow to pick. You would use, username and the client resource owner flow. So that's part of the flexibility of OAuth. Cool. Great. Question?
I think the authorization code grant type, the first one, that is the real devil. Because the joke that you put that it's not possible for the microservice to tell, okay, I'm the microservice, that sort of thing. But a lot of description tend to say that the most general use case is your authorization code grant type.
Yeah. So
That sort of thing. These two are very nice, that two use cases that you showed.
Yeah.
It covers a wide gamut of use cases, basically.
Mm-hmm.
But the authorization code is the most complicated, and it looks like it is the most hyped up.
Right.
On the
Yeah. So I didn't. So,
different vendor products and so on.
yeah. So what the comment is that a lot of the OAuth things tend to get explained using the authorization code flow, which I'm intentionally staying away from explaining in the interest of time. It is not very useful for things that don't have a UI. If you do not have a user interface that can pop up a browser to kind of do the authorization, it's not very useful.
Even the UI case, basically, it's difficult to understand the use case sort of thing.
Okay.
The owner might be in London, and the
Sure.
user might be in New York, and then the user wants to access the thing of the owner, and the user agent goes to that place, and there it takes permission, and then the control comes here.
Yeah.
It's
So.
not been explained properly at any of the vendor side how the use case is to be implemented, sort of thing.
Sure. So.
Usability of that sort.
So here's what I don't want to do right now. I'm interested in telling the big picture. I'm happy to go offline and discuss specific details of that use case. I do have an actual demo that does do authorization code flow and client credentials. I want to make sure to get to that. Okay. So to basically kind of complete it, we're now at the OAuth 2 layer. The next layer up in the standard stack is OpenID Connect. And OpenID Connect builds on top of OAuth 2, JWT, and TLS. And it defines a standardized identity token. So it gets much more opinionated. There's no more, like the JWT spec says all fields are optional. OpenID Connect has like 15 fields that are required. Okay, and you have no choice about the fields. If you want to be OpenID Connect, you must follow those. So as an example of that, all these things that I showed you from JWT that were optional now become required. Okay? So the next thing we want to talk about is actually, let's take a look at some microservice security patterns. Now that we have the basic foundation of the protocols that we are using, let's take a look at what happens. We have some sort of user interface, but some of the data comes from the one microservice. This other data comes from this one. The blue one comes from the blue microservice. What do we do is, like, let's say it's a web app. Is each one having AJAX calls directly to the, the corresponding microservice? That would be, who would say that's a bad idea? Anybody else? Okay. Yeah. It is a bad idea. So what most of you do is you go like, I know what to do. I'm going to put a UI microservice. And this thing is going to be, my browser, my native app will talk to it, and then it will talk to the other microservices and kind of get data and other stuff. Then it turns out that your browser has more like this is a desktop app. It has more space, so it requires more data. Your mobile apps needs a subset of that data or in a different order. So you invent a whole entire filtering parameters that you start sending to this thing to just get who has that? Like no, a UI microservice where you filter out data and stuff. Thanks. Yeah, most of you do. It starts looking ugly. Recommendation: read about this thing called backend for frontend. It's a pattern for building microservices, which says actually split that up into different ones. Okay. So the big picture behind this that I'm trying to get to is you're going to end up with a client layer. You're going to end up with what we would refer to as edge microservices. Think of the edge microservices as where requests enter the microservice ecosystem. And from there, they're going to flow to other stuff. So as an example, let's say it's an online banking application. My web client is going to talk to my microservice for that particular, the BFF, which will turn around call money transfer, which money transfer might turn around and call currency exchange and email template and various other microservices that are involved. So now the question becomes this. So what we've decided on is when microservices call each other, we're going to include a JWT token. And what we want the pattern to be is that a microservice gets a request that includes a JWT token. The microservice checks that the JWT token is valid. It checks that the token has the correct scopes in it. And the information in the token is all that we need to make this happen, to make a security decision. We're going to keep the model simple because we can't have the developer of the microservice has a huge task to write a secure one. Otherwise, we'll be insecure. Does that make sense to you guys? Everybody agree? Got to keep it simple. So this is super easy to implement with Spring Boot-based, Spring-based framework. So I'm going to actually switch to the demo and show you this. Okay? So here, I have a system that consists of the following microservices. I don't know if you guys can read it. I've got here a customer. I've got a menu service and an order service. So these are two microservices that don't have a UI. And I've got an application called the customer portal where customers can go and make orders from the restaurant. And so that does have a UI. So what happens here is if I try to visit localhost 8082, oh, I get redirected. Watch me do it again. Localhost 8082, I'm getting bounced to my login server. Okay, this is my OpenID Connect. This happens to be the UAA, which is part of Cloud Foundry. Now I'm going to log into this, and I'm going to click Sign In, and it's going to take me to my application. And in here, I can go and I can look at the menu to see, hey, what orders do I want to place? I can also go and look at my access token. So this is the token that was given to this application by the OAuth server. Who's with me so far? This token is sent to the menu microservice to view the menus. It's also sent to the order microservice to place orders. You guys with me? Okay. Now let's take a look now and see. not from the point of view of the UI, but from the point of view of the developer of the order microservice. So let's go take a look at the code. So in the order microservice, I would like to write a method to view which orders I've placed. And you can see here, the magic is this guy right here. That's all I have to do. I put at pre-authorize. This is standard Spring Security annotation to say, before you call this method, please check that some conditions are met. And the condition that's being asked is to look inside of the OAuth 2 scope and check that the scope order.me is listed in the token. Who's following me so far? Raise your hand. Okay. So now if I switch to go here, let's go back and take a look at this guy here. You can see that the token that I have has a scope of OpenID, menu.read, order.me. If this scope did not exist, that code would not execute. Comments, questions?
The scope, can we say that the scope is a sort of authorization mechanism?
Yeah, the scope is, this concept of scope is basically a list, an array of strings. The concept is defined in OpenID Connect. And it's just like whatever you want it to mean. Some scopes, like OpenID, has a very specific meaning that's laid out by the OpenID spec. Others are yours to make. You make your own scopes. So in the 4-hour version of this, we go through how to design the scopes and what should be a scope, what shouldn't be a scope, what's too fine-grained, what's too coarse-grained. There's a lot more to it, but I just want to focus, make sure everybody understands the mechanics. So the second thing that I kind of want to show about this is that when I look at the application itself, you can see the second annotation, at enable resource server. Just by adding this annotation to my application, I now have said that this application will refuse to talk to anyone that does not present it with a valid JWT token. I didn't have to do anything. Just say at enable resource server. Who's like, this is simple? I'm not a security specialist myself, and I can do this. So I'm excited about that. Now, you're probably wondering, well, how does it actually validate that token, right? And the answer is, again, Spring Boot to the rescue. By the way, Chris, I love that feature, Command++. Eclipse has that now. Is that when I configure my Spring Security, I just say Spring Security OAuth 2 resource. You can see here that there's a JWT Key URI. And this is where the application can go to get the public key that's used to sign the token. So if I go to my browser and I go to localhost 8080 UAA /token _ key. Oops. Wrong. There you go. This is just a public endpoint on the server that issued the token. I can go to that URL, and I can retrieve the actual public key that's used for signing that JWT token. Who's with me so far? So to kind of review the story and recap, as a developer of a Spring Boot application, I go into my configuration file and I specify the URL where I can grab the certificate that's used to sign the tokens that I will receive. Step 2 is I go on my application and I say that I enable at resource server to say I'm an OAuth 2 resource server. I want a JWT token. Step 3 is when I write my code, I use the at pre-authorize annotations to specify conditions and use the information in the token to make an authorization decision. Yeah, question?
Yeah, can JWT, or is there a pattern where JWT can be used for like data integrity? So I go to one microservice to fetch customer data
Yep.
that needs to be fully sent back to some other service, but with it came some sort of signature that I need to give to the other microservice so that he makes sure that I don't fiddle with that customer.
Correct.
Now, where would you put that token if I had to like fetch 5 or 6 different things, put them all together in one big payload? Should like
Right.
they be children in the payload?
Yeah. So the question is, what if okay, so it's a very good question, which is, I need to call other people, and those people don't trust that I didn't tamper with their inputs, so they're expecting my inputs that I sent to them to be signed. And this is a use case of JWT where it's not, you can use JWT for it. It's not an OAuth 2 use case. It's you're now making your own token. You use there's Java libraries like JWT, which make writing JWT tokens super easy. You go like builder.makeMeOne, sign it. You just make your own tokens. So that's basically.
Or would you just use HMAC or something instead? Like,
Well, you could use HMAC with JWT, because JWT gives you the choice. Remember the JSON Web algorithms gives you a long list of algorithms that you could potentially use with your JWT token. And all of these have standard libraries. So what I like the most about JWT is if you go here to jwt.io, I forgot to do this, but if we go down, you can see all the .NET libraries, the Python libraries, the Java libraries, JavaScript, Ruby, Perl, Elixir, I don't know what that is. Sounds like a drink. Go, Haskell, okay? You get the point? You got a JWT token, you can pretty much work with it in any programming language. So that's the reason why I would use that. Okay? So I'm just going to go back here to my screen and try and wrap up with some final thoughts about it. So if I have like a money transfer service calling a currency exchange rate service, the currency exchange may not care who I am as a user. It just knows, it cares that money transfer is authorized to call it. Does that make sense to you guys? So it's like making the distinction between services that actually need to know who the user is versus services that don't. And arguably, money transfer doesn't even need to know who I am. It needs to know which application is invoking it. Is it the web application, the native mobile application, the branch application? And based on that, it would kind of decide about things. Because a lot of security that this comes up in the 4-hour version of this is what should be in the JWT token, what should be in the payload. There's a lot of things that you would instinctively want to put in the header that should absolutely not be there. It is part of your business logic. Put it where it belongs in the payload. So here's how it gets a little bit more interesting. Let's say my money transfer service wants to send out an email. First, it wants to at the end of the transfer to say, "Dear Adib, we've transferred $100 from your Canadian bank account to your US bank account. And the exchange rate was blah, 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 and it was done on this date." So maybe I have a microservice that I can call and I can say, "Hey, the email template microservice, can you run template number 27? Here's the JSON with the input to that template. It gives me back nicely formatted HTML, which I can then take and actually email." Now, that particular application might have a single-page GUI, which marketing people use and legal people use to go in and edit these particular templates. Here's the French version, the English version. Here's the one with the blue fonts, the one with the green fonts. And so when the email template service is being called by the single-page app, it absolutely cares who you are, because it wants to know whether you have permissions or not. Like, are you allowed to approve something or not? But when it's being called from the money transfer side, it doesn't care. It just says, do you have the permission to execute a template? So this is where, when you start looking at these particular things, the design of the scopes and what you put in the token becomes very important. And I'm out of time, so I apologize for, I did my best to do the 4-hour workshop in 50 minutes. So I'm happy to take questions for the rest of the day offline. Okay? So these are all the things I skipped over. So thanks very much. Okay, cool. Thank you. All right.